question 14, we're dealing with perpendicular lines and finding points of intersection. So we've got to find an equation which is perpendicular to the line of this, but that also passes through the point P. So the first thing I'm going to do is find the point P, and that's because I can do that straight away with these two lines. So where these two meet, the value of y will be the same. So where they meet, 2x plus 3 is equal to y, but so is 4x plus 2. I'm going to solve this. There's more letters on this side, so letters to this side, numbers to that side. Take away 2x, leaves me with 2x plus 2. Take away 2, leaves me with 2x is 1. Divide by 2, leaves me with x is 1. If x is 1, 2x plus 3 is y, so 2 plus 3 is y, which is 5. So the point of intersection is 1, 5. Now, the rule is, if you've got a perpendicular line, then it goes through the same point is what we're going to need, the matching point, but the gradient is as opposite as possible. The official rule is m1 times m2 is equal to minus 1. So basically, what do I times 2 by, the gradient, to get minus 1? And the answer is minus a half. If you half 2, you get 1, you need a minus to get a minus. I always like to think of it as you need it as opposite as possible. The opposite of 2 is 1 over 2. This one's positive, so I need to make it negative. So my new line is going to be y equals minus 1/2 of x plus c. Remember that y equals mx plus c is the general rule, gradient times x plus the intercept. So what I need to do is work out the value of c. Now it goes through this point 1, 5, because that's what it says in the question, find the equation which passes through this point. So I'm going to put 5 and minus 1/2 of 1 plus c. So 5 is minus 1/2 plus c. So I'm going to add 1/2. So 5.5 is equal to c. So the general equation is y equals minus 1/2 of x plus 5.5. There are neater ways of writing it, that will get you the mark. You could multiply it all by 2 to say 2y is minus x plus 5 to plus 10 even, but it's really not worth it. I would just leave it, that's fine. Question 15 is a bounds question. With bounds you always go half above and half below. We're on the upper bound of the area of the rectangle. Well, area would be a times b, length times width. So if I want the upper bound, the biggest answer you can get from this is the biggest possible value of a and the biggest possible value of b. So the largest possible of a is 8.3 and half above, and the largest possible of b is 3.6 and half above. So that's what we're going to type into our calculator. Which is 30.4775. Just write down all the figures on your calculator, so that's what I'm going to leave it as. For part B, when it talks about the appropriate number of significant figures, I'm going to find the lower bound as well. This is the upper bound, so that what I'm going to do as well is find the lower bound. So half below for A, half below for B, and I'm going to work that out. Okay, so once you've figured that out, that's 29.2875, and that's the lower bound. I'm just going to write that there. The upper, the maximum that the area can be, is 30.4775. Now, for a suitable degree of accuracy, we're looking for where these two numbers round to the same value. And because of the way it's turned out, the only way that they'll round to the same number is if I make it to one significant figure. If I do two significant figures, this will round to 29 and this will round to 30. So to make it work so they get the same value, we would have to round to one significant figure. So the answer is 30 to one significant figure.